So hello everyone and welcome to this next lecture on Python Power Electronics, and this is a continuation of the series on control systems, control functions. So as before, I'm going to start off by going to my website. And in the website I go to the download section where I look at papers. And as before, read this paper, Control Structure. This is a paper which describes the different control variables in a control function. So I'm going to open this. So I would suggest to go through this paper before you start it. I've already said it in the previous lectures. Otherwise, at least have it open. So we've been going through some of these concepts, and in the previous one I talked about variable storage. So far I have covered inputs and variable storage. In this one I'm going to talk about static variables. So now let me go over to my command line, and I'm in my home directory. I go into virtual environment. This is where my environment is. I first have to activate my virtual environment, so that is going to be python to test in activate. So now I'm in my virtual environment. Let me just confirm I have the right Python version. Yes, I do. Now that I have this, I will go into this directory which has my simulator. So I'm using the web application, and the web application is a Django interface, as you might know. And I will launch this server. So all this is there in all the previous lectures. There are several lectures which describe exactly what need to be done. I would suggest you reference some of those. In this I will just continue to save time. So the server is up and running at this particular address. So let me go over to my web browser and launch the server. So it's already running, and I go to simulation library, where this is the only simulation, because this is the only simulation I've done so far. I will load the simulation, and this is the same one which was before, that is diode rectifier with switch load. We are now trying to control this switched part. So I just have to save this and continue. Add circuit files. I don't need to change any of the circuits. There are 3 files. They will stay as it is. All I have to do is process the circuit schematics. Process circuit schematics is important because when you first start up a circuit simulation, you must always process the circuit schematics, because this is when this simulation, this instance of the Django server knows about your entire circuit topology. So the circuit does not have any detectable errors. There was never any change anyway. So we go back to the main page, edit circuit parameters. All of them are the same. You just have to get to this page and go back to the main page, and that's it. So the most important here is edit control. So I'm going to configure this control, and this is where we were last time. So we have inputs. We have 3 inputs: an ammeter, a voltmeter, and 2 voltmeters, and we have a few variable storage elements. Now in this lecture I'm going to talk about static variables. Now before I jump to why we need static variables, actually I should have done this even in the previous lecture. I'm going to talk about why we need these special variables, things like static variables and variable storage elements. What is the special need? So let me jump over to my editor, which is Atom, and let me create another file. I shall call this file testcontrol.py, and this is just to examine some concepts. So to begin with, let me just define a function. Let me say test control, and let me just print hello world. Perfectly okay. So now that this is done, let me go over to my, now the web browser is running. Let it run. I'll just open another terminal, and let me go back to my, because I must get back, so I must always be in my virtual environment, because if I'm not in the virtual environment, I may not have the right version of Python. So let me do this again. So I have the virtual environment running in 2 tabs. That's perfectly legal. There's nothing wrong with it. So now I go back to diode rectifier, and this is it. So you see, this is, where is the file? Yeah, testcontrol.py. This is the file that I just created. So let me just confirm whether I have the right version of Python. Yes, I do. It's 2.7.13. Okay, let me clear the screen. So now that we have this, I am going to run the file testcontrol.py. Now it says there's an invalid syntax because I have to add a bracket. So let me add this bracket, and nothing happens because I haven't called it. But the most important thing, we have no errors. So now let me call this function. So it says hello world. So now that we got it going, we have a function going. I'm now going to describe some of the other aspects. So in Python, it's very important to know that there is no need to declare a variable. Like for example, if you come from a background like C, C++, you will have to do something like int a, and only after this int a, and only after this can you use a. Otherwise you can't use it. If you try to do int a is equal to 10 without that declaration, it'll give you a syntax error. Alright, but in Python that's not necessary. A is equal to 10 is a perfectly valid statement, because in Python you do not need to declare variables. Variables come into effect when they are first used. So a is equal to 10 will create the variable a, that is create an object for that variable a, and create it of the type integer because we are assigning an integer. It's as simple as that. So supposing I say now print a, what would happen? It says a is equal to, it gives you this number 10. Why? Because I am printing a. So now what you need to understand is a variable has a scope. In this function, let me just I will just increase the font a little so that it is visible. Okay, so it's a little visible now. Okay, so I am now saying a is equal to 10. This variable a has a scope. In this function, I am defining the variable a. It exists within the function. It does not exist outside the function. Let me do that here. Let me do print a again. Okay, let me go back to my terminal and let me run this. You see what's happening here? It is giving me the output 10. Alright, because when I call the function, it launches this function, it assigns 10 to the variable a, it prints it out, so I get a 10. But after that, I get a syntax error. Why? I get a name error. Name a is not defined. And look at which function. It is line number 7. Let's go to line number 7. This is line number 7. It says the variable a is not defined. You might think, well, I defined it here. But this definition is within the function. It is local to the function. It does not exist outside the function. Similarly, I could also define a outside. So I could get if a is equal to 100. Alright. Now you might be a little confused. Which variable is it going to use? Let's go find out. And you see the error disappeared. But I now have two values of the variable a. First, the function is called test control. In that it assigns a is equal to 10. So before I'm in the beginning, all the way in the beginning, I'm giving the variable a the value 100. I am then calling test control. Alright, that's what happens. I call test control. It gives the value a of the number 10. Alright, this is reassigning. Now here when I print this value a, this is within the function. It is going to look at the scope of the variable. It will first look if the variable a exists within the function. If it exists within the function, it will use this value of a. Alright, it will not use this value of a because it will use the value of a that is defined within the function. And when we jump out of the function, we print the value of a again. It uses the value of a in the global scope because it does not have access to this value a here. This is within the function only. It is local to the function. It cannot be accessed outside the function. So therefore, now let me do the opposite here. Let me comment out this line. So now what happens? I have the same value in both cases because guess what? Initially I'm giving the value I'm giving the variable a the value 100. When I launch the function, I'm saying print a. This statement looks for the value variable a. It does not find it in the local scope because I have commented out the line, but it finds it in the global scope. So it prints out the value of a in the global scope, that is 100. And when I come out and print it here again, I get 100 again. So I get 100 twice. So what I'm trying to show with this entire exercise is, when you define anything within a function, let's say for example, let me jump over to this and let me look at here, these are values. It has copied all these statements inside this function. Now it is a function. If it is a function, it obeys all the laws of a function. So now you see here what's happening. I have created two variables x and y. These variables x and y are local to this function. Okay, so if I try to access it here, it'll give me an error. I cannot access it outside the function. So now the problem is this. Let's say for example, in this particular case, I want to do a summation. So let's say for example, I say I want to do sum plus equal to x. Okay, on right, sum plus oh no, this is not a good one. Sum var, because it's actually giving, because when you it gave me a highlight, and highlight means it's actually a reserved word, so don't use it. So let's say sum var is equal plus equal to x. Now when this happens, what do you think will happen? Let me go back and run this equation, or rather run the simulation. So let me go back to the main page, or rather main control page, go back to the main page. When I go to view output, now I can run the simulation. Now I'm going to run it. It says simulation is running, but I'm pretty sure it won't be running. Let's come here. And you see, I get an error. And I get exactly the same error that I got here. Pretty much the same error. Unbound local variable. Local variable sum var referenced before assignment. You see this? It's almost the same as this. A is not defined, referenced before assignment. Okay, let me go back and tell you what happens. This sum plus equal to x means sum var plus x. Alright. Now, you might think to yourself, there's nothing wrong with this equation. But actually there is, because I am taking sum var, I am assigning the sum of sum var and x and assigning it back to sum var. Okay. The problem is this. What is the first initial value of sum var? It does not exist. I have not defined it here. I have not defined it anywhere. It does not exist. Okay. So that's why it's giving this error. Now I could get rid of this error by saying sum var is equal to 0. I could do that. Let me go back. Okay, let me stop the simulation and let me restart the simulation. Okay, let me go back and check. And you see now there is no error. This is working. So now the simulation is running. Okay, the simulation is running. Let me switch this off. And let me go back here. So as before, the entire block of code has been copied exactly into this function. Now the problem is we've gotten rid of the error, but have we achieved what we want? Let's say for example, I want to sum this way. I want to sum variables. Okay, so like for example, I would like to sum. I'll give you a better example. Let's call this current integral is equal to 0.0. Okay, and now let me do a current integral of I source 1, and let me multiply it by the time instant of simulation. So I am going to do 1 minus 6. Alright, you might think, sorry, e minus 6. Now you might think, what does this mean? I am integrating the current All right. So basically, I am taking I'm integrating the source current. So I'm measuring. I have the measured value of source current. I am going to multiply it by the time step, simulation time step, which is 1 microsecond, and I am going to add this to the integral value, and I am initializing the integral value. So this is pretty simple. This is how you write an integrator. Now, the problem is this will not work, and I'll tell you why. Let me now create another control stored variable and let me store this. So let me go back and switch this. Stop this simulation. Okay, I'm going to stop this simulation. I'm going to go back to the main page, go back to my edit control, go back to configure control, and I'm going to add another variable storage element. Okay, let me call this, let me go all the way down, let me call this store var3. Okay, initial value 0.0. Store, yes, absolutely. I want to store this. So save variable storage. So now I have a third variable storage element. So now let me use this to plot what that integral does. Because this is the reason. This is the reason why we have that variable storage element. You can debug your control. So before that, let me go back to my control sheet and let me call store var3 is equal to current integral. Alright, so what am I doing here? I have defined a local variable. I am trying to do an integration and I am storing this in my variable storage element so that every time this function runs, I am plotting this in the output data file. And so I can now plot this and see what happens. So let me go back and see. So now that this is done, I can run this and I can now add a plot. And this plot is going to be var store 3. We call this start plot. I'll add a waveform. I need only one waveform. Actually, you know what? I can add ammeter source ISRC. So I'll add this just for the sake of it. I'll add another one. This is the most important because I'm going to add that variable. And here I'm going to add store var3 and I'm going to say current is the integral of the current. So let me see. I'm done with everything. So let's save this plot and let me plot it. Let me go over to my file browser. Let me look at diode rectifier and here it is. So this tells you what it is. So this blue line is the source current. The orange line is the integral. Alright. Now nothing happens. You see the integral is almost 0. Let me plot it again. Let me go back. Check it out, and it is still 0. And if you let the simulation run, you will find it is always at 0. Well, it's not actually at 0. And to give you that idea, let me just let me change the syntax a little. Let me go and remove this time step part, but let me divide it by 2. Now I'm going to tell you why I'm dividing it by 2. When I run the simulation and plot it again, it will become obvious. Okay, let it run for a while and let me plot it. And you see the value here. So you see what's happening. I am taking what I actually would like to do is to take a sum of this current, but I am just putting the divide by 2 because if I had given just I source and not this, if I remove this, what would have happened is these two waveforms would have been exactly the same, and I want to show you how. I want to show you two different waveforms. Now what's happening back here again? So I am assigning integral is equal to 0 and I am adding this current. But the problem is every time the function is called, at every simulation instant, I am always assigning integral to be 0. So the result is this value current integral 2 is actually just this I source 1 by 2, nothing else, because integral is equal to 0 means that this value is always 0. So really speaking, what are we achieving? We are not achieving a summation. So you might say this is the offending statement. Let me get rid of this. But if I get rid of this, it won't work, because when I want to run this, when this tries to execute this equation, it says it doesn't know the value of current integral because I haven't defined it before. And that's where the problem lies. Let me go back and check it. Just for the sake of it, let me run the simulation once more. Let me plot it again. Let me go back, close this. And you see that's exactly what's happening. The integral of the current is exactly half the value of the source current. Alright? So we are not achieving an integration, we are not achieving a summation. So now let me go and see how we can fix that. So now that we have commented it out, let me go and run it again and let me see what it happens. It will give you an error. So let me stop it and let me run it. Now the unfortunate part is, if there is a syntax error, it does not come up here. You actually have to see it in the command line. I still have to fix this. Alright, this is a bug. I have to fix it. So it says here unbound local unbound error. You see, the simulation is not running. Alright, the simulation is not running. For example, if you look at circuit output.dat file, you see it is 0 bytes. Let me open this. It is an empty file. Why? Because it has created the file, but the simulation is not running. And because simulation is not running, nothing is happening. So here lies the problem. If I want to do a summation, how would I do so? The problem lies that I need this initialization should not happen within the function. It should happen outside the function, inside the simulator. Alright, so I'm going to take this out. So which means this cannot be a normal variable. This has to be something else. And that's what this static variable is. So if we go back to this, a static variable only means this is a variable that is not, like, let's go back here again and I'll show this function. Okay, every time this function runs, it will create the value variable a, and when this function exits, alright, it will destroy this value a. Static variable means that the variable is not destroyed at the end of the function. That means when the function exists, it does not destroy, it will not destroy this value, this variable. If I declare it as a static variable, it will store this value variable inside the simulator. Alright, and we've seen this in the previous case, and I'll show you again. It will store the value of this variable in the simulator, and in the next simulation instant, it will provide you this stored value. So let me go back to my simulator and let me create this value. Let me go back to the main page, edit control, configure control, and now here in static variables, add a static variable. So I'm going to add a static variable, desired variable name in control code, and I am going to use this one. So let me just copy it just to make sure I don't make a spelling mistake. Alright, initial value of the output 0.0. Now here you see what I'm saying, this initialization which I was doing right above, now I am doing it here, and this initialization will happen inside the simulator, not in the control function. Okay, so I can initialize it to anything. I'm starting at 0, but it can be 100, it can be -10, whatever value you choose. It has to be some finite value. So let me stay with the static variable. Now that I have saved the static variable, let me go back and run this simulation and I'll show you what happens. view output and run. So as before, we go back here, we check, no error. So we are okay, simulation is done. So most important, let me go back here and look at this underscore control.py. You see here, it has changed. Now, let me go through this entire thing. The first three are the inputs. We've already talked about them, I won't talk about them again. Now, after that comes this one. You see what's happening? Current integral, alright, this is the variable we defined as a static variable, is equal to interface static and something. So whatever variable name we give, it is stored within this circuit simulator in this special variable. You don't have to worry about it, that's none of your business. All you need to know is it is stored inside the simulator, initially starts off at the initial value we give, which is now 0.0, and it is assigned to the variable that we define. So now this variable can be used, and that is what has happened. Current integral is integral plus I source divided by 2. And let's go back here and see what happens. At the end, we do the reverse process. We take the value of current integral, whatever changes we make within the control function, we take this value of that static variable and we move it back, and we store it back into the circuit simulator. See, this is the same variable as the one above. So the simulator stores the value of the static variable, and before every control function it gives it back to the function, and at the end of the control function it takes it back from the function. This is how it stores the value of a static variable. So let me go back now and see what happens. Alright, let me plot this. And it has done something. Let me come here. And you see, well, actually what has happened is, I should go switch it off. It has gone out of bounds because we are probably too big. So I am going to go back and do, because I had removed this time step just so that we could see the value variable. Actually, that's not an integral, we are doing a sum. So let me go back and let me run this now. So now I'm doing an actual integration. Alright, I am taking the measured value of the current, multiplying it by the time step and adding it to the existing value of the current integral. So it is circuit simulation is running. Let me plot it again. Well, actually it's still small because I am still plotting it with respect to this. So yeah, it won't work because an integral is still going to be very small because we are still measuring it with the time step. So that's how it is. Usually we use a KPI controller, but it's kind of stuck. So usually we use like a PI control and we put a PI control gain. So that's a different aspect totally. So at this point, what I would say is we have achieved a sum. Let me go back and plot it again just for the sake of it. So it is a very small variable. Actually you will have to zoom in, but even zooming in won't really help much because you see here it is actually a very small value because we are multiplying it by the time step, which is 1 microsecond. So whatever is the value of the current, we are actually multiplying it by 1 microsecond. We are dividing it by 1 million. So how much do you get? 100 divided by million. Yeah, just do the math. So but what's important to know is we have achieved, okay, let me, instead of dividing it by that topic, let me divide it by 1000. That may be a slightly better solution. Now I'm just trying to get a reasonably good value that we can plot and we can see how the summation happens. So let me plot it. Yeah, so you see here, this is a summation. This is a summation which is divided by 1000, so it's like it kind of doesn't blow up, but at the same time it's not negligible either. Let me plot it again after a few cycles. So what needs to be taken out from here is a static variable is extremely important when you want to do control, because in almost all control you will need either a summer like an integral, or you may need the previous value. For example, if you're doing a filter implementation, like you're implementing a low pass filter, a low pass filter will need to store the value of the filter in the previous instant. So you will need x of n and you will need x of n minus 1. That is very common in a low pass filter or many other digital forms of control. So therefore a static variable is very important. So let me just plot it again. Yeah, so ideally what has happened is it is now summing it above into, and it gives you this, whatever, looks a little weird, but it gives you this fairly weird output. And you can see here the summing usually takes place in this part. It stays constant because after that the current is 0, and it returns back to a negative, it returns back to a lower value when this current is in its negative wave, has a negative value. So this kind of seems like a working simulation. It gives you the idea how we can use static variables to do things like summation. And as we go on, I'm going to show you how much more interesting control can be done using these static variables. So as before, I'm going to stop this lecture now, otherwise it'll get too long. This is the end of the third part, and in the next one I'm going to talk about time events. So in time events, I would suggest that you look through this variable, that is time event variable, and for time events you might also want to go and check this other paper out called timing scheduler. So this will be, I'm not sure when I'm going to make this video, but this will be at that time. This paper is going to be really helpful, because this paper tells you how timing events are, how the control functions are scheduled within the circuit simulator. So anyway, this is a later function. For now, I'm going to stop this lecture, and thank you so much for watching. If you have any doubts, by all means contact me by email or on Facebook or anywhere else. And I hope to see you soon. Bye bye for now, and thank you again for watching.